Hello and welcome to a new video. In this video, we are going to discuss mathematical expressions in Python. So let's start with the basics. Multiplication is done by the star operation. So if you want to multiply two numbers, you will do 6 star 3, for example. Division is done by the slash operation. So to divide two numbers, 6 slash 3. Addition is done by the plus sign, subtraction by the dash sign or the negative sign, and power is done by 2 stars. So if you want to raise 2 to power 8, you write 2 double star 8. This will be equal to 2 raised to power 8. There are some rules regarding operator precedence. So if you have expression with mixed of operations, you start with whatever inside the parentheses, then you evaluate the power, then multiplication and division, then you end up with addition and subtraction. So let's see an example on how to apply these rules. So here we have a multiplication, we have addition, division, and a power. And here also we have parentheses. So the first thing we need to do is to start with whatever inside the parentheses. So notice here I have addition and division. And we know from the table that division has higher precedence. So I'll start by dividing R over 100. Okay, then I have addition. So I will add 1 to it. Now I am done with the parentheses. And outside the parentheses, I have multiplication and power. So we know from the table, power has higher precedence. So I will raise this quantity here in the rectangle to power n. Then I will multiply it by b. Okay. Now a question. What do you think about this expression? 1 plus r over 100 to power n multiplied by b. Now, are these two equivalent? The answer is yes. Why? I will start with the parentheses again. Then I have power and multiplication, and we will start with the power. So like before, we started with the power in this expression after the parentheses. Then I will multiply it by b. So it is still the same expression. Now, what if I want to raise this expression to power n by b? So I want to evaluate this basically. What if I want to evaluate this? The answer is you write it as follows. You write 1 plus r over 100, the power operation, then parentheses, and star b. So you start with this parentheses, you do whatever inside, then you multiply n by b, then you raise the entire expression right here to power n by b. Okay, so what about if you have two operations of the same precedence in the same statement, the same expression? So let's start with the first one. What is the correct answer of 10 over 2 by 5? Do we do it like this? So you start by the division, you calculate this to 5, you multiply by 5, this is 25. Or do we calculate the multiplication first? So it will be 10 over 2 over 10, which is equal to 1. Which one is the correct answer? The answer is this. Why? Because division and multiplication are left associative, which means if you have a mix of them in an expression, you start from the leftmost operation and you move to the right. You start from the leftmost operation. So you start with the division, then we move to the right. Okay, what about the second expression, where we have 10 to power 2 to power 3? There are again two ways to calculate this. So let's see. First way is to do 10 to the power 2, which will result in 100, then raise everything to the power 3. So is this equal to 100 to the power 3? Or instead, we do 2 to the power 3 first, then we raise 10 to the result. So 2 to the power 3 will be what? Will be 8. So 2 to the power 3 is 8, 10 to the power 8. Which one is the correct answer? The answer is this. Why? Because power is right associative, which means if you have multiple power in one expression, you start with the rightmost one. So here we start with this. Okay, what do we do with it? We raise 2 to the power 3. This will give us 8. Then you do the left one. So you take 10 and you raise it to the power 8, which gives you 100 million, which is the correct answer. You can try these in Jupyter and see the results for yourself. Okay. So division. How much is 5 over 2? When I write 5 over 2 in Python, what would I get? When you go to Jupyter and you write x equal to 5/2 and you print x, if you run the code, you get 2.5. Okay, so the question is, how do I get the quotient and the remainder? Okay, so you know that the quotient of 5 divided by 2 is 2. So if I ask you how many 2 is in 5, you will answer 2. This is the quotient. What is the remainder? What is the remainder of dividing 5 over 2? The remainder is 1. And you know this from the long division. So if you divide 5 over 2, this is 2. You multiply, you get 4. You subtract, you get 1. The number up here is the quotient. The number down here is the remainder. So how do I get the quotient and the remainder in Python? You get the quotient by double slash. Okay, this operation is called integer division because it is division that has an integer result always. Okay, and how do we get the remainder? By this percentage sign. Okay, this is known as the modulo operator. So let's see this in Jupyter. Let's create a new cell and write q equal to 5/2 r equal to 5 percentage sign over the modulo operator 2 and print q and print r. Let's add more details here. I'll write q equal to make it clear, and here I will write r equal. Let's run this. I get q equal to 2. The quotient is 2, and the remainder is 1. So let's continue. Assume n is 1729. What is n modulo 10? So if you don't know how to do this, just try the long division operation by 10. What do we get? 172. Do the multiplication. You get 1720. Subtract, you get 9. So this is the quotient. This is the remainder. So the answer here is just 9. What the answer here, we already get it. It's 172. What about over 100? You can do the operation. However, the answer is just 29, right? If you do 1729 over 100, we get 17 here. 1700 down here. You subtract, you get 29. This is the remainder, and this is the quotient. How about n modulo 2? The answer is 1. And here is the general rule. Any odd number modulo 2 equal to 1, and even number modulo 2 equal to 0. This will be very useful later when we discuss conditional statement. So far we've seen the uses of print function. Okay, so let's discuss more functions. There are some functions that returns the result. Okay, let's explain this. There is a function called ABS, short for absolute value. So you can give this an input like -5, okay, or we call this argument, remember from the previous video, and the absolute value will basically take the absolute value of this argument and it will return it. So the output, or we call it return value of this function is 5. So if you give it, for example, -1, it will return 1. If you give it 6, for example, it will return 6. Okay, so some functions will return the result for you. What else? There are a function with optional arguments. Okay, so what is an example of this? There is a function in Python for rounding. So if you want to round a number, for example, 2.3, you give it to the round function, it will return 2. You can specify to how many decimal places you want to round. For example, I can give it 2.344, and I want to round this to 1 decimal place. So I want 1 decimal place in the result. Round will give me back 2.3 as my result. Notice the number of decimal places, which is a second argument to the round function, is called optional argument, because we can use the function round without providing any second argument. So it's optional, totally optional. Also, there are some functions with arbitrary number of arguments. So the absolute value function takes 1 argument, round can take 1 or 2. We've seen a function already with arbitrary number of arguments, which is print. So print can take as many arguments as you wish. It will print them in order or display them in order. Another function is min. So you can give it as many numbers as you wish. For example, 25, 26. Sorry, you can give it 25, 26, -1, -4, -10. It will always return the minimum among those arguments. So here it will give you -10, for example. Similarly, I have max, okay, which receive an arbitrary number of arguments. All right. So there are a collections of functions that perform common mathematical operations. For example, if you want to take the square root of a number or a variable, you use the function sqrt, and you provide the number as argument. For example, if I write sqrt and provide 25, this will give me 5. There are functions for cosine, sine, and tan. Also, there is a function to calculate e to power something. So if I write x5 in Python, this will calculate e to power 5, e being the natural number. Also, there is a function to convert a number or an angle from radians to degree and degrees to radian, which are degrees and radians. Also, there's a function for log. So if you write log 25, this is actually calculating len 25. So basically, the base here is e by default. If you want to change the base, you provide a second argument, which is an optional argument, like in the round function. So basically here, if you want to calculate log 25 with base 10, you just write it as a second argument. If you don't write it, the default base will be e. So you will be calculating len of 25. Okay. So let's see how to use these functions in code. So I'll start by showing you how to use, for example, the absolute value function. I provided -2, and print y, I will see 2. Also, you can see the round function, y equal to round 2.4. This will give you, if you print y, this will give you 2. Similarly, you can write y equal to min 3, 5, 1. And if you print y, this will be 1. So basically, min is calculating the minimum among the arguments, and it will return it. So whatever return value the function gives you, you can store it in a variable. So here, absolute value is returning 1, returning 2. You store it in a variable y. Round is returning 2. You store it in a variable y, and so on. Also, you can immediately use a function that returns a value inside print. So for example, I can write print absolute value of -5. So here I will start by calculating the absolute value of -5, which results in 5. Absolute value will return the result 5, and print will take it as an argument and print it. So I get 5 here. So let's go back to the round function again. So if I write y equal to round 2.5 and x equal to round 3.5, if I print y and x, what do you think the result will be? So what you expect is that y will be 3 and x will be 4. However, when you run this, you get something else. So let's explain why Python behaves like this. So take the number 2.5. What is the number immediately above 2.5? You get 3. What is the number immediately below? 2. In the case of 3.5, above it you have 4, and below it you have 3. The round function is rounding in the case of 0.5. Okay, so this is only when you have something 0.5. Python will round to the nearest even number. So in the first case, you have 2 and 3. Which one is nearest even? You get 2. So you will round down. Okay, and you have 2 as a result. And in the case of 3.5, you have 3 and 4. Where is the nearest even? Number 4. So you will round up, and you get 4 as a result. So it's just a small note about the round function. Okay. Now let's try to use one of the functions we've seen that will do a common mathematical operation. So let's start with the square root function. I write y equals QRT 25, and then I will print y. In this case, you see a name error. So SQRT is not defined. Here, to use this function, we need an additional statement. Okay, you need to tell Python where this function is coming from. So you will type from math import SQRT. So let's explain what is going on here. When you write this, you are telling Python from this file, okay, or we call it a module in Python, from the math module, import the function named SQRT because I want to use it in my code. So once you run this code here, you get 5.0. You need to do this for any function you've seen on the list. So for example, if you want to use the cosine function, you want to write from math, import cosine, then print cosine 25, for example. Once you run this, you get your result. Now you can make a shortcut by importing everything from math. So from math, import star. And now you can use any function in the math module. So for example, sine of 30. You run this, you get the result. However, this method is not recommended in general. It's not recommended because it can lead to something called name conflict. So Usually, what is recommended is import just the functions you are planning to use in your code from a specific module. All right. So let's get back to the slides. How to calculate these operations or how to write them in Python. This is a quick exercise. X plus y over 2. You might say you write it like this. However, this is wrong because this will calculate x plus y over 2, which is not the same as this expression here. So the correct way is to write it as follow. You write x plus y inside a parentheses, then you divide by 2. Okay, how about the second example? Is this a correct way of doing it in Python? The answer is no. If you want to multiply two quantities or two variables here, you need to use the star operation. Multiplication is written by using the star operation like this. And notice how we don't need parentheses in this example. Okay, so what about the third one? You've already seen this before. You write r over 100, 1 plus r over 100, everything inside parentheses, then you raise to power n. Okay, so what if I did it like this? Is this correct? The answer is no, because this will be evaluated to 1 plus r over 100. The 100 will be to power n, which is not the same as the expression in the left in the table. Okay, what about the last one? The last one, I need the square root function, so I will write from math, import sqrt, and I will write, for example, c equal to sqrt a double star 2 plus b double star 2. Now, another way of doing this without importing, so this is one way. Another way is to write immediately z equal to a double star 2 plus b double star 2, then everything inside the parentheses, and I will raise this to power 1 over 2. Notice how I need the parentheses here, because otherwise I will be raising to power 1. Okay, then dividing everything to 2, which is not the same. Actually, this way here, the second way is the way to do a root other than the square root. So for example, if you want to calculate the third root of 64, you write it as 64 double star 1 over 3. Okay. So let's solve this exercise. Write a program that calculates the volume of sphere with radius r equal to 2.4, and the calculation is done by this formula down here. So let's move into Jupyter. So r will be defined as 2.4. Then I will calculate v to be 4 over 3 multiplied by multiplied by r cube. So pi is a constant inside the math module. It's written as this, so I need to import it from the math module as I imported a function. So pi is a variable in the math module, or a constant to be more specific. You import it by writing from math, import pi. Okay. Then you multiply it by r to power 3. Now you can ask yourself a question, do I need parentheses anywhere? The answer is no, because you will start with the power, then you do the division, then you will multiply, which is exactly what you want in this calculation. So I grab V and I run the code, I get my result. If you are curious, you can import pi and print it to see its value alone, and you see 3.14, 15, and so on. Okay, so pi is again a constant inside the math module, just like the functions we imported from math module. You can also import constants from the math module. Okay, now here is the important question. Why do we need to import? We used absolute value, round, print, and other functions like min and max without any importing. So why do I need to import right here? Let's explain this. So inside Python, there is something called Python standard library. Okay, so this is basically a collection of functions, okay, that comes with your Python installation. You don't need to install anything else. Okay. However, there are two categories in these of these functions. One category is which you don't need import to use, so no need for import, and the other category is you need import. So what are these categories? The first category is which you don't need to use import for, like absolute value, min, print, and so on. These functions are called built-in. Okay, you can think about them as they are part of the language itself. So you can use them immediately. You don't need to import anything. The other collection of functions are not built in. So you need to tell Python where to get them. So for example, the square root function, the cosine and sine functions are not built in. And you have to tell Python that they are coming from what we call the math module. Now, again, a module is just a file on your own computer. Once you download Python, you have the Python standard library, which is divided into modules. Okay, so related functions, like these functions here, are all related. They will be stored in the math module, which is just a file. Okay, so you'll tell Python from math import this function, or for example, import a constant. Okay. So the last item I'm going to show you is the documentation. So any programming language, it has some official documentation. Okay. So most of them most of them will have official documentation where you can see basically what are the functions available for you, what is the meaning for each function, what is the argument accepted by each function, what is return value for each function, and so on. So let's take you to the browser where you can see this documentation right here. This is the page for the built-in functions. You can go to the Python official website to see them. Just Google built-in functions in Python documentation. Here are all the functions that are built in. You can see, for example, print. If you click on it, you see a description of the function print, the type of argument accepted, and so on. Also, you can see other functions we've seen before, like absolute value. You can see round and the letter R right here, and so on. Here is also the documentation of the math module. So you will have all math functions in the math module that you can use to perform different expression. So that's it for this video, and I will see you in the next one. Thank you for watching.